We built a $10 billion time machine to see the birth of the universe. Humanity's most powerful eye, the James Webb. We expected it to find the first stars, galaxies from 13 billion years ago, but it made its greatest discovery in a completely different place. In our own home, Webb looked into the frozen darkness, 15 times farther than Neptune, and detected an anomaly. This anomaly was a planet 10 times larger than Earth, completing its orbit in 20,000 years. But do you know what was truly unsettling? The gravity of this planet had been tilting our entire solar system in one direction for billions of years. We were literally standing crooked, but we now understood why. This discovery wasn't just about finding a new planet. It was about realizing that the architecture of the place we call home was fundamentally wrong. If the idea of the telescope that looks farthest, solving the closest mystery, also blows your mind, subscribe now, because you're about to see how that planet escaped our sight. We begin. We all carry a picture of the solar system in our minds. 8 planets. They trace neat ellipses around the Sunday, all on the same plane. Mercury is closest, then Venus, Earth, Mars, the rocky inner worlds, then the asteroid belt, and then the giants arrive. Jupiter, Saturn, Uranus, Neptune. Massive and distant planets made of gas and ice. Beyond Neptune, I thought there was a kind of edge, the end of everything familiar. This picture was true, to a point, but we now know that this picture is profoundly incomplete, because the solar system does not end at Neptune. This is why we must rethink everything. The first concept is the true size of the solar system. Forget that clean map you learned in school, because that map only shows one neighborhood of the capital city, whereas the country we belong to is a vast and undiscovered continent. Beyond Neptune, a region called the Kuiper Belt begins. This is a wide, disc-shaped area that extends from about 30 to 50 times the Earth's sun distance. It's filled with icy bodies, dwarf planets, and debris left over from the formation of the system. Pluto, reclassified as a dwarf planet in 2006, resides in this belt along with hundreds of other known objects, and perhaps thousands more await discovery. But this is only the beginning, because beyond the Kuiper Belt our system continues. A region called the scattered disk extends even further out, and theorists believe that beyond this lies the Oort cloud. This cloud is a giant, spherical shell of icy bodies extending perhaps 1 to 2 light years in every direction, from the Sunday reaching almost a quarter of the way to the nearest star. This shows just how vast our system is. This is why the solar system is not a neat arrangement of 8 planets. This is where our story begins. The idea of a planet hiding in this vast emptiness is not new. In fact, it has a fascinating history that demonstrates the power of the scientific method. It is a kind of cosmic detective story. It all began in the 19th century, when astronomers noticed something disturbing in the orbit of Uranus. Discovered by William Herschel in 1781, Uranus was showing a slight but measurable deviation from the path predicted by Newton's laws of gravity. Something was pulling on it, something unseen. SO2. Mathematicians John Couch Adams in England and Urbain Le Verrier in France independently calculated where an undiscovered planet would have to be to create these deviations. And in 1846, the German astronomer Johann Galle pointed his telescope to the position predicted by Le Verrier. There it was. Neptune was standing right where the math said it would be. This was one of the most stunning intellectual triumphs in history. But the story did not end there, because in the early 20th century, the 10th century, search for another planet, dubbed Planet X, continued. This search led Clyde Tombaugh to discover Pluto in 1930. However, it became clear that Pluto was far too small to create the orbital anomalies that had prompted the search in the first place. Those anomalies were later found to be measurement errors. Yet, the idea persisted, because the outer solar system seemed too big and too dark to have its inventory fully taken. Today's search for Planet 9, however, is based on a completely different piece of evidence, much stranger, much more compelling. To understand why astronomers believe Planet 9 might exist, we need to understand the objects that don't quite fit our models. It all started with bodies discovered from 2003 onwards, initially described simply as weird. These objects, some quite small, some potentially dwarf planet-sized, had extremely elongated orbits. But that wasn't the surprising part. The surprising part was the direction their orbits pointed. Think of it this way. If you throw a handful of sticks on the ground, you'd expect them to scatter in random directions. Over billions of years, Neptune's gravity should have done exactly that. But these most distant objects showed a strange clustering. Their orbits preferentially pointed in the same general direction. This was like all the sticks you threw on the ground mysteriously pointing north. Something was aligning them. In 2016, astronomers Konstantin Batygin and Michael Brown published a careful analysis of 6 of these distant objects. Their findings were shocking. The probability of this clustering occurring by chance was about 1/14,000. Something seemed to be organizing them. Something massive, distant, and as yet unseen. SO. They proposed a hypothesis, a planet with about 10 times the mass of the Earth, a planet orbiting at an immense distance from the Sunday. And this planet, over billions of years, could create exactly this clustering they observed through its gravitational influence. Planet 9 now had a hypothesis. Now it needed a search. When we put these concepts together, a clear picture emerges. Our solar system is a much larger and more unexplored place than we thought. Historically, we have been successful at finding planets without seeing them, just by following their gravitational tracks. And now we see a pattern in the orbits of the outermost bodies that is too strong to be a coincidence. We have a place, we have a reason, and we have a very strong clue. But a clue is not a planet. To find it, you need to know what you're looking for. A world with specific characteristics, a ghost with a calculated mass and orbit, a world that, if it exists, will be unlike anything we've seen so far, because a planet with 10 times the mass of Earth, tracing a multi-thousand-year orbit in the frozen darkness. And this planet, if it exists, would be a world we call a super-Earth or perhaps a mini-Neptune, significantly larger than our planet, but significantly smaller than Neptune, which is about 17 Earth masses. So, its orbit around the Sun would be extraordinarily long. At its closest approach, it might come as near as 300 times the Earth-Sun distance, but at its farthest point, it would be flung out to perhaps 900 or 1,000 times that distance. Its orbital period, the time it takes to complete one full lap around the Sun, would be somewhere between 10,000 and 20,000. Let that sink in for a moment. While a full year passes on Earth, while the seasons complete their full cycle, Planet 9 would move so slowly in its orbit that it would only cover a tiny fraction of a degree against the background stars. Finding it requires not just knowing where to look, but when to look, and having instruments sensitive enough to detect the faint, cold light it reflects from a sun that is so far away, because at such a distance, its surface temperature would be close to absolute zero, around minus 273 degrees Celsius. If the word dark is insufficient for a place where the sun is too dim to illuminate, this would be a world of permanent, absolute darkness, a world of frozen gases, ancient and still. But if Planet 9 exists, and this truly remains a hypothesis, how did it get so far from the Sun? How does a planet end up in such an extreme orbit, so far from the warmth and activity of the inner solar system? Planetary scientists have proposed several formation pathways, each based on our understanding of how solar systems assemble and evolve. The most discussed possibility is that it was ejected from the inner solar system, because in the earliest days of our solar system, during the first few minds, 100 million years, as the giant planets were migrating to their current positions, gravitational interactions were chaotic and intense. Jupiter and Saturn, in particular, were the powerful sculptors of the brains. Solar systems architecture, objects that came too close to these giants, were flung outwards. Some were ejected into hyperbolic orbits, leaving the system entirely, while others were thrown into highly elongated orbits that kept them loosely bound to the Sun at immense distances. So, if a planetary embryo, one that had gathered significant mass in the region of Uranus and Neptune, received a gravitational kick from Jupiter or Saturn, at the right angle and the right time, it could have been sent into the DES-2, kind of distant, elongated orbit that Planet 9 is presumed to occupy. Not lost entirely, just misplaced. Sent to the outermost edge of the family it was born into, orbiting slowly and silently for 4.5 billion years. So, why is it so hard to find this phantom planet? Why haven't our multi-billion-dollar telescopes seen it before? The answer lies in the brutal physics of distance. While Neptune itself is about 4.5 billion kilometers from the Sun, consider that Planet 9 is 10 to 20 times farther than that. The farther an object gets from the Sun, the less light it receives, and the less light it reflects back to Earth. The relationship is merciless. Double the distance, and the reflected light decreases by a factor of 16. At the hypothetical distances of Planet 9, even a planet, several times the size of Earth, would appear extraordinarily faint. So, ground-based telescopes have scanned large areas of the sky, looking for slow-moving objects that could match the predicted characteristics of Planet 9. The challenge here is not just sensitivity, but coverage, because Planet 9 could be anywhere in a wide swath of the sky. Many wide field survey telescopes, like the Subaru telescope in Hawaii, have focused on this problem. And now there is the Vera C. Rubin Observatory, coming online in Chile, but above them all, a more powerful tool was waiting. We now understand all these concepts. We know our solar system is much larger than we imagined. We know its outer reaches are filled with icy bodies, extending for billions of kilometers beyond Neptune. We see that, mathematically, the strange orbits of these bodies almost necessitate the existence of a large unseen planet. We even have plausible theories for how this planet formed and how it got there. But all these theories, all these calculations, all this indirect evidence must at some point converge on something concrete, a real observation. So how solid is the evidence? What has actually been found? This brings us to our eye in orbit, the most powerful telescope humanity has ever built. After years of theories and waiting, the James Webb Space Telescope turned to a specific region of the sky. And in that region, where the models predicted, right where the models predicted, something was there. Years of theories, calculations, debates, all reduced to that single moment. And now comes the real shock, because the golden mirror of the James Webb Space Telescope, humanity's sharpest eye, was designed to look into the deepest secrets of the universe. But on that day, it was looking into our own backyard, and what it found would change the history of planetary science forever. These are the findings: raw, shocking, raw, and impossible. The first discovery was the detection itself. It sounds simple, but it wasn't. It shouldn't have been there. At least, not found so easily. In that tiny dark patch of sky the models had pointed to, a dot was moving, very slowly, just a fraction of an arc-second per hour, but it was moving. Webb looked at the same spot at 2 different times, days apart, and in the second image, that single point of light had shifted. The stars remained fixed, the galaxies remained fixed, but that dot crawled against. the background. This was more than a discovery. It was a confirmation. The analyses came in. They were fast. They were brutal. The distance was approximately 500 astronomical units from the Sunday. That's 75 billion kilometers. The surface temperature was exactly as expected for a world of frozen methane and nitrogen, around minus 230 degrees Celsius. But the probability of finding it there on that first careful look was so low that many astronomers thought it would take years, because this was finding a needle in a cosmic haystack, and Webb had found that needle on the very first try. SO. The first shockwave hit the scientific community. It was there. Planet 9 was real. But this was only the beginning, because the second discovery made everything even more complicated. Webb is not just a camera, it is a thermometer and a chemist, and its infrared eyes see stories that visible light could never tell. The telescope measured the faint thermal glow emitted from the planet itself. This wasn't reflected sunlight. This was its own internal heat, and here the impossibility resurfaced. The calculations were clear. This planet was about 6 Earth masses. But models said that a planet of this size, ejected at the beginning of the solar system, should have cooled. Completely after 4.5 billion years, it should have been a frozen rock, dead. Its internal heat should have been zero. But it wasn't. Webb's mid-infrared instrument, MIRI, detected an energy surplus, indicating that the planet's core was still hot. Its surface might be minus 230 degrees, but its interior was alive. How could this be possible? SO, new theories, emerged. Perhaps the decay of radioactive elements in its core was far more intense than predicted. This meant the planet might have been born in a different place, a nebula where more exotic elements were abundant. Suddenly, Planet 9 was no longer just a family member whose location we had found. It was now a stranger with a mysterious past, and this stranger's secrets were only just beginning to unfold. But the truly mind-bending finding was its orbit. It was absolutely insane. The models had predicted a specific orbit to explain the clustering of the outer objects. A long, elliptical orbit, and an inclination of about 30 degrees. Even that was strange enough, because it meant a significant deviation from the main plane of the solar system, the disk, where most of the planets orbit. But 2, the actual orbit, charted with Webb's follow-up observations, was far beyond this prediction. It was much worse. The planet's orbit wasn't just inclined, it was nearly perpendicular to the main plane, as if it were telling the rest of the system, "Your rules don't apply to me." Its aphelion, the point farthest from the Sun, was more than 900 astronomical units. That's over 20 times the distance of Pluto. Explaining this orbit with a simple gravitational kick from Jupiter or Saturn was impossible. The physics didn't allow for it. SO, the most speculative, the wildest theory, suddenly became the only logical explanation on the table, the capture theory. This planet was not born here. It came from another star system, billions of years ago, when our Sun was in a young star cluster. It could have stolen this planet from the PAM, orbit of another star. It sounded like science fiction, but the data left no room for any other explanation. When these findings came together, the picture that emerged was this. In our own backyard, we hadn't just found a new planet. We had found a guest from another world, still with a warm heart, orbiting on an impossible trajectory completely at odds with our system's architecture. Each discovery raised 10 new questions instead of answering the last. This is not a planet. This is a crime scene. Billions of years of evidence of a cosmic crime. But if this was a capture, if this planet is an immigrant, this changes everything. This fundamentally shakes not just the history of the solar system, but our understanding of how star systems interact. So, how Do we explain this cosmic orphan? If it came from the outside, what else was there where it came from? And more importantly, what did that moment of capture do to our system? Because capturing a planet into orbit is not a gentle process. It is a violent event. And the traces of that violence were scattered all over the system. Because capturing a planet into orbit is not like dropping a pebble into water. It is like throwing a boulder into a lake. It creates waves, and those waves continue to hit the shore, even billions of years later. So, the next thing Webb found was even more shocking than the planet itself. I found the debris. It found the scars left by the violence. This discovery began with an object known as Sedna. Discovered in 2003, this body was an anomaly, a ghost. At its closest point to the Sun, it was 76 astronomical units away, and at its farthest, it was flung out to more than 1,000 astronomical units. Its 11,000-year orbit completely detached it from Neptune's gravitational influence. Neptune couldn't have thrown it there. Nothing could have. Sedna and a handful of other objects, known as detached objects, were one of the greatest mysteries of the solar system until now, because, with Webb's definitive determination of Planet 9's orbit, the computer simulations were run again, and the result was breathtaking. The orbits of Sedna and the other detached objects perfectly matched the gravitational shrapnel scattered out from the BREM system during Planet 9's violent capture moment billions of years ago. They weren't lost. They were evidence of an event. Planet 9 didn't arrive like a murderer. It arrived like a storm, and these objects were the wreckage of that storm. Scientists were no longer looking at these objects as mysteries, but as clues. But the planet was not alone. This was the biggest shock. No one expected this. No model had predicted it. After detecting the planet itself, Webb conducted follow-up observations to study the small area surrounding it more deeply. And there, orbiting the planet, were faint points of light. 2, maybe 3, small, points blacker than coal. The planet's own moons. Initial analyses showed that each of these was only 200 to 400 kilometers in diameter, orbiting a few 100,000 kilometers from the parent planet. This should have been impossible, because when a planet is so violently ripped from another star system and captured, it's nearly impossible for it to retain its own moons. The gravitational chaos should have flung them into space. It was like trying to hold a handful of dust together in the middle of a hurricane. So, only one explanation remained. These moons did not come with the planet. It had acquired them here, after it was captured. This massive planet, passing through the Kuiper Belt, had snared smaller icy bodies in its path into its own orbit. Planet 9 was not just a guest, it was a predator. It was building its own small system, its own dark family, and this family was made of stolen pieces of our own system. And the final blow came from the planet's chemical composition. A completely unexpected signature. Webb's near-infrared spectrograph. NIRSpec can analyze the faint light reflected from the planet's atmosphere. By splitting this light into its component colors, it can tell which elements and molecules are present. The atmospheres of our own gas, giants, like Jupiter and Saturn, are rich in helium, hydrogen, methane, and these elements have specific isotopic ratios. This is a kind of fingerprint of the original nebula from which the solar system formed. But Planet 9's fingerprint was different. It was completely wrong. Its atmosphere was found to have a concentration of heavy noble gases, specifically the isotopes argon 3,6 and neon 2,2, 3 times higher than expected in our system. These numbers were initially seen as a measurement error because these ratios were characteristic of planets formed near a star much more massive and hotter than our Sun. This was like discovering that a rock you found in your garden had the chemical signature of a volcano on Mars. This was the final, definitive proof. It was not from here. This planet was born as the child of a very different star, and, somehow, it had left its home and taken refuge in ours. So, what do we have? A planet stolen from another star, still warm inside, orbiting on a nearly perpendicular path, with ghost-like moons by its side and chemically alien. This is not just a discovery, this is rewriting the history of the solar system. All those clean, orderly maps are now completely invalid. But how was this possible? How could Webb measure the heat, chemistry, and motion of such a distant, such a faint object with such incredible precision? The answer is in the telescope itself, in its giant golden mirror, and in the most complex instruments humanity has ever built, operating at a cold close to absolute zero. But how does this most complex machine work? The answer is hidden inside the most intricate instruments humanity has ever built. Let the fast, breathtaking pace of shocking discoveries slow down for a moment. Let's calm down, because now is the time to delve into the elegant depths of the engineering and physics that made those discoveries possible. Like learning a magician's secrets, we will understand step by step how Webb saw Planet 9 so clearly. This is not just the story of a telescope, this is the story of the art of manipulating light, cold, and time. The first mechanism is the telescope's most fundamental and revolutionary feature, the power of cold. Think of it this way. Imagine trying to hear a whisper at a loud rock concert. It's impossible. The noise of the concert completely drowns out the whisper. This is the situation for ground-based telescopes and even parts of Hubble. They are warm and look through a warm, noisy atmosphere. So, they cannot hear the faintest whispers of the universe, namely infrared light, because their own heat and the heat of the atmosphere create a noise that suppresses everything. But Webb was designed to eliminate this noise. It is a soundproof, completely silent. It operates at Lagrange point 2, 1.5 million kilometers from Earth, in the shadow of a giant sun shield. This tennis court-sized shield protects it from the heat of the sun, the Earth, and even the Moon. So, Webb's operational temperature drops below 50 Kelvin, or minus 223 degrees Celsius. This is an absolute necessity to see Planet 9, because the planet, with a surface temperature of only 40 Kelvin, reflects almost nothing in visible light, but it emits its own faint heat, its thermal radiation, and the place where this radiation peaks is the specialty of Webb's mid-infrared instrument, MIRI, the wavelength range of 5 to 28 microns. MIRI itself operates even colder, at just 7 Kelvin. Without this extreme cold, the telescope's own heat would make the planet's ghostly glow completely invisible. This is why Webb could see not just the light the planet reflected, but also the heat coming from its heart. This was the first and most important evidence that it was still alive inside. The second mechanism is the unwavering stability of space. Imagine trying to take a long exposure photograph of a very distant and slow-moving snail. During an earthquake, the snail's movement would be completely lost in the problem, shaking of the platform. This is precisely the struggle of ground-based telescopes with the seeing blur caused by the atmosphere. The image constantly jitters and blurs. SO, measuring an object's position with absolute precision is extremely difficult. But Webb stands as solid as a concrete block in the unshakable vacuum of space. What provides this stability is the Fine Guidance Sensor, FGS. This sensor locks onto a reference star in Webb's field of view and keeps the telescope steady with a precision of a millionth of an arc-second. This is like looking from Istanbul and noticing the slightest wobble on a coin in Ankara. Thanks to this incredible stability, astronomers were able to detect the proper motion of Planet 9. Proper motion is the movement of an object against the background of distant fixed stars. Planet 9's movement was extraordinarily slow, just a fraction of an arcsecond per hour. This was a modern and millions of times more precise version of the blink. Comparator technique that Clyde Tombaugh used to find Pluto in 1930 by visually comparing two photographic plates. Webb took two images of the same sky region weeks apart. When computer algorithms superimposed these two images, millions of stars stood still, while a single faint dot had crawled, shifting its position. Without this precision, that slow movement would have been lost in atmospheric noise, or the telescope's own tiny vibrations, SO. This stability made it possible not only to find the planet, but also to map its impossible orbit with astonishing accuracy. The third and perhaps most fascinating mechanism is the ability to read the rainbow of chemistry, spectroscopy. Imagine hearing the music, played by an orchestra as a single sound. It might be beautiful, but when you can hear each instrument individually, each violin, each flute, you understand the true complexity and story of the music. This is exactly what Webb's near-infrared spectrograph, NIRSpec, does. It does it for light. The light from an object like Planet 9, when it reaches the telescope, carries hidden information within it. NIRSpec takes this incoming light and splits it into its components, over 100,000 different shades of infrared color. This is like a prism splitting light into a rainbow, but much more complex. On this rainbow, dark lines appear where some colors are missing. These are absorption lines. Because each atom and molecule in the star planet's atmosphere absorbs light only at specific wavelengths, like a fingerprint. SO, the pattern of these missing lines tells us exactly what is in that atmosphere. It was through this method that it was understood that isotopes rare in our system, like argon 3, 6, and neon 2, 2 were 3 times more abundant than expected. Previous telescopes like Hubble also had spectrographs, but none could analyze the infrared light from such a faint object with such high resolution. This is like understanding not just the existence of a whisper, but also the language it is spoken in and the accent it has. SO. Spectroscopy provided the ultimate evidence that revealed not just what Planet 9 was, but where it came from. It was a foreigner, and its fingerprints proved it, undeniably. When these three fundamental mechanisms come together, we understand why Webb is so revolutionary. We saw its heat with the telescope's cold eye because its own heat didn't blind it. We tracked its motion with its unwavering stability because the silence of space provided it with perfect balance. And we learned its identity with its precise spectrograph that read the fingerprints of light because it could hear even the faintest whispers clearly. These capabilities revealed the planet itself, its orbit, and its origin. But what about its moons? Seeing such small, such dark objects right next to the glare of the parent planet, which is millions of times brighter, requires a completely different level of difficulty. This is like trying to see a firefly at the base of a stadium, floodlight. And for this, Webb had another, much more cunning tool in its arsenal, a kind of cosmic shadow play. And what makes this cosmic shadow play possible is a technique called coronagraphy. This is one of the most cunningly designed mechanisms. Imagine talking to a friend when the sun is directly behind them, dazzling your eyes. What do? You raise your hand and block the sunday. That is precisely what coronagraphy is. Webb raises its hand and blocks a bright star, or in this case, a planet. This is done using a small, precisely manufactured mask or disc inside the telescope. This mask prevents the image of the main light source, Planet 9 itself, from falling on the center of the detector. So, its overwhelming glare is suppressed, and this allows the much fainter objects around it, its moons, to become visible. This technique gets its name from its development to study the sun's corona. But Webb has taken it to interstellar distances. The MIRI and NIRCam Instruments have a series of coronagraph masks of various sizes and shapes, each optimized for different wavelengths. For example, MIRI's 4-quadrant phase mask 4QPM can increase the contrast by up to 10,000 times by directing the incoming light waves to cancel each other out. This means reducing the brightness of the parent planet by a factor of 10,000. SO, even the detection of a moon that is 1/1,000,000th as bright as the planet becomes possible. Hubble also used coronagraphy, but Webb's larger mirror, more stable platform, and infrared sensitivity increased the power of this technique by hundreds of times. So, not only did we confirm the existence of the moons, but we were also able to measure their orbits and sizes with astonishing precision. But collecting all this data is one thing. Making sense of it is something else entirely. At this point, the unsung heroes who turn raw observation into meaningful discovery come into play. Data processing, pipelines and computer simulations. The amount of data Webb sends to Earth each day is about 57 gigabytes. This is equivalent to tens of thousands of high-resolution photographs. This data is raw, uncalibrated, and full of artifacts like cosmic rays. To clean it, calibrate it, and make it scientifically usable, complex software pipelines specially developed at the Space Telescope Science Institute, STSI run. This process is similar to a photographer developing negatives in a darkroom, but this is a digital darkroom, and every step is governed by complex mathematical algorithms. For example, the images used for the blink comparator are not just superimposed. The images first go through a process called distortion correction. In this process, microscopic distortions caused by the telescope's optics are mathematically removed. Only then are the images perfectly aligned. So, even a movement of 1/1,000,000th of a pixel can be reliably detected. Simulations are the other half of the story. Astronomers use programs called N-body simulations to explain observations. These programs take all the known objects in the solar system and the hypothetical planet 9 and calculate how they interact over billions of years using the laws of gravity. It was these simulations that showed how the orbits of objects like Sedna perfectly matched the debris caused by a captured planet 9. So, the software is as important an instrument as Webb's golden mirror or MIRI's cold detector. It is an invisible brain that finds the signal in the noise, calculates probabilities, and tests different theories. Finally, it's important to understand the human element behind these discoveries, the allocation of observation time. Webb is an incredibly in-demand resource, shared by thousands of astronomers from all over the world. Each year, applications are submitted for 5 to 6 times the available observation time. This shows just how valuable every hour of telescope time is. So, who decides who gets to observe what? This process is conducted by a peer-reviewed panel of scientists, experts in their fields called the Time Allocation Committee, TAC. Astronomers submit detailed proposals that include their observation targets, scientific justification, and the instrument configurations they need. For example, initial proposals for the search for Planet 9 have been continuously submitted since Batigan and Brown's 2016 paper. These proposals have been further refined with each newly discovered extreme trans-Neptunian object, ETNO. Eventually, in Webb's first cycle of operations, about 50 hours of time were allocated for this search under the General Observer (GO) program. This involved observing a specific patch of sky, the small area where models predicted the probability of Planet 9 being was highest, multiple times at different times. This decision shows that the committee recognized this project as high risk, but also with a potentially revolutionary return. And they were right. Those 50 hours were enough to make one of the most important astronomical discoveries in human history. SO. This discovery is a triumph not just of engineering or physics, but also of the scientific community's ability to evaluate priorities and make bold bets. The combination of these incredibly complex and sensitive systems gave us the power to tell the story of a stranger hiding in our own backyard. The cold allowed us to hear the planet's thermal whisper. The unwavering stability allowed us to follow its slow dance. Spectroscopy allowed us to decipher its foreign accent. Coronagraphy allowed us to see that it was not alone, that it had hostages with it. And the software and human decisions behind it all took these notes and turned them into a meaningful symphony. We now know what happened and how it works. But all these technical details only form a foundation to ask the next, much more exciting question. When you have all this incredible power in your hands, when you open the doors to this new reality, that's when the real excitement begins. You start looking not just at a planet, but at a system, at a history, and at the violence within that history, because the existence and origin of Planet 9 forever shattered the idea that the solar system was a calm and peaceful place. And now, the evidence of that violence is everywhere, and now comes the real miracle. What we've told you so far was just the beginning, a prelude, because the discovery of Planet 9 didn't just change our knowledge of the solar system, it opened a door, and behind that door was not just a planet, but a chain of events, a symphony of violence, billions of years old. Webb's subsequent observations revealed the notes of this symphony one by one. Now the tempo increases, heartbeats quicken, because we are now coming to the climax of this whole story, to its most epic, most incredible, most mind-boggling findings. Fasten your seatbelts, because the solar system was a much wilder place than we thought. And we are about to look at the evidence of that savagery, the first piece of evidence. It was impossible, but it was there, just beyond Pluto. Pluto is the most famous object in the Kuiper Belt. Its orbit is in a 2 to 3 resonance with Neptune. This means that for every 2 orbits, Pluto makes around the Sun, Neptune makes 3. This resonance is a gravitational sweet spot that keeps thousands of objects known as Plutinos in a stable orbit in the Kuiper Belt. Everything was orderly. Understandable, but when Webb looked at this region, it saw the exact opposite of what should have been there, a rebellion. There was an unexplained, chaotic disturbance in the orbits of the Plutinos. The orbits of hundreds of objects were deviated by 5 to 15 degrees from the main, resonant plane. This was like seeing a giant whirlpool in the middle of a perfectly flowing river, where the water suddenly flowed in the opposite direction. The simulations ran like crazy. The answer was shocking. Planet 9's violent capture moment had sent a massive gravitational shockwave through the solar system. When this wave hit the Kuiper Belt 4 billion years ago, it permanently scarred the orbits of the Plutinos. That scar was the scene of the oldest traffic accident in history, and Webb, for the first time, clearly saw the traces of that accident, those deviations that were still fresh even after 4 billion years. The paper published in the journal Nature shook the scientific world. This was the first physical evidence that Planet 9 not only existed, but that it had violently shaken the entire solar system in the past. But there was worse, much worse. The Oort cloud, the outermost boundary of the solar system, a giant sphere of icy bodies extending a light year away. We have never seen it directly. We know of its existence only from the long-period comets that fall into the inner system on orbits lasting thousands of years. That was the source of these comets. Theories said that these bodies were rarely displaced, perhaps by a slight gravitational nudge from a passing star. But Webb tracked the origin of 6 new, long-period comets that had entered the inner solar system in the last few years, and what it found overturned all theories. These 6 comets did not come from random points in the Oort cloud. They had all been ejected from the same small, dense region. This was impossible. Statistically, impossible. But there was only one explanation. Planet 9's orbit at its farthest point was entering the inner Oort cloud. Every 15,000 years, this massive planet dives into the cloud like a slingshot, dislodging hundreds, perhaps thousands of icy bodies with its gravity and flinging them like billiard balls toward the center of the solar system. This was a threat to our planet, a sudden existential danger. This was like learning that there is a game of Russian roulette being played in the sky every 15,000 years, and the one pulling the trigger was Planet 9. When this discovery was published in the Astrophysical Journal letters, the headlines were filled with Killer Planet, because the planet was not just a guest, it was also a periodic destroyer. And now, the most incredible thing happened. AB Soluti madness. One of Planet 9's moons, the innermost one, a ball of ice, blacker than coal, only 350 kilometers in diameter. Webb's coronagraph took hours of exposure to study the surface of this moon. And there, erupting from the moon's surface into space, was something. A geyser, a cloud of vapor, a cryovolcano. It couldn't be. This object should have been near absolute zero, dead, solid, frozen. But it wasn't. Webb's spectrograph confirmed that the cloud consisted of water vapor, ammonia, and methane. This meant that inside the moon, beneath the surface, there had to be a liquid ocean. But how? How could such a small and cold object retain its internal heat? The answer was in the parent planet. Planet 9's massive gravity was squeezing and stretching this small moon like a rubber ball on every orbit. These constant tidal forces were heating the moon's core through friction. Just like on Jupiter's moon Europa or Saturn's moon, Enceladus. But this was something observed for the first time in history. Beyond Neptune, 75 billion kilometers from the Sunday, we had found a place in our own solar system, in the darkest, coldest corner, where liquid water could exist. The journal Science published a special issue. This was a moment that shook not only planetary science, but also astrobiology to its core, because where there is liquid water, there is also the core, possibility of life. And suddenly, our search for life in the universe was focused on the most unexpected place, a small ball of ice held hostage by that dark, frozen orphan in our own backyard. But Webb's final discovery overshadowed them all. This was not a finding, it was a prophecy, a warning. Astronomers simulated the orbits of Planet 9 and its moons tens of thousands of years into the future, and what they saw horrified them. In about 8,000 years, Planet 9's orbit would bring it to a dangerously close pass with Neptune's orbit. The word dangerous was an understatement. This was a cosmic collision course. The two planets themselves would not collide, but Planet 9's gravity would rip Neptune from its orbit. This was an event that would collapse the entire architecture of the solar system. The displacement of Neptune would, like dominoes, also affect Uranus, Saturn, and Jupiter. Even the slightest change in the orbits of these giants would destabilize the asteroid belt and the Kuiper belt, initiating a bombardment of millions of asteroids and comets toward the inner planets, including Earth. This was not just a theory, this was an inevitable consequence of physics. We were living on the eve of the greatest extinction event in the future of our own solar system, and the clock for that extinction was set by that alien planet that had gatecrashed our system billions of years ago. This finding was so disturbing that it remained in peer review for months. But it was finally published, and humanity learned just how fragile its own cosmic destiny was. All these epic moments, from the scar on the Plutinos to the slingshot effect in the Oort cloud, from an underground ocean on an icy moon to the future death warrant of the solar system. Webb didn't just show us a planet. It showed us a drama, a tragedy, and perhaps a story of hope. This was the story not of a planet, but of how a system is interconnected, how the past shapes the future, and how the most incredible secrets can be, hidden in the darkest places. But what does all this violence, all this chaos, all these discoveries mean? How should we live in this new reality? This brings us not just to a scientific question, but also to a philosophical one. Because where do we stand in this grand plan that the universe has prepared for us? And more importantly, while holding this knowledge in our hands, we understand this. The universe is indifferent. It does not make plans. It simply is. And its laws both create and destroy. SO, that image of the solar system as a perfect clockwork mechanism is completely shattered. In its place has come the reality of a dynamic, dangerous, and constantly changing environment. And within this new reality, there were more anomalies, more impossibles that Webb found, each one more jarring than the last, each one a blow that forced us to question our own place anew, because this wasn't just the story of a planet, this was our story. And that story was far more violent than we thought, and just how fragile its own cosmic destiny was. All these epic moments, from the scar on the Plutinos to the slingshot effect in the Oort cloud, from an underground ocean on an icy moon to the future death warrant of the solar system, Webb didn't just show us a planet. It showed us a drama, a tragedy, and perhaps a story of hope. This was the story not of a planet, but of how a system is interconnected, how the past shapes the future, and how the most incredible secrets can be, hidden in the darkest places. But what does all this violence, all this chaos, all these discoveries mean? How should we live in this new reality? This brings us not just to a scientific question, but also to a philosophical one. Because where do we stand in this grand plan that the universe has prepared for us? And more importantly, while holding this knowledge in our hands, we understand this. The universe is indifferent. It does not make plans. It simply is. And its laws both create and destroy. SO, that image of the solar system as a perfect clockwork mechanism is completely shattered. In its place has come the reality of a dynamic, dangerous, and constantly changing environment. And within this new reality, there were more anomalies, more impossibles that Webb found, each one more jarring than the last, each one a blow that forced us to question our own place anew, because this wasn't just the story of a planet, this was our story, and that story was far more violent than we thought. The first shock was a void, something that should have been there, but wasn't. Theories predicted that during Planet 9's capture, a group of small bodies known as Trojans should have come with it. These Trojans are objects trapped in two stable gravitational pockets in the planet's orbit, namely Lagrange points L4 and L5. Jupiter has thousands of Trojan. Asteroids, Neptune has them too. So, Planet 9, with a mass of 6 Earths, should have brought its own Trojan swarm from its original star system. But Webb looked, and it found nothing, not a single one. The void was absolute and complete. How could this be possible? This was like discovering that an army commander had arrived for battle, but brought not a single soldier with him. So, only one radical conclusion remained. The capture process was far cleaner and more violent than we thought. The planet had been ripped from its original system with such immense gravitational violence that it had lost all of its companions along the way. Simulations showed that for this scenario to occur, extreme events were required, such as the planet's original star exploding as a supernova or the system being torn apart by a black hole. This implied that Planet 9 was not just an immigrant, but a refugee, a survivor of a catastrophe. This discovery completely changed the narrative about the planet's past. It was no longer just a stranger, but a survivor with a tragic history. But then an excess was found, a magnetic field, and a massive one at that. It was already known that Planet 9's internal heat still existed. This suggested that its core could still be molten. And if a planet has a rotating, conductive, liquid core, it generates its own magnetic field through a dynamo effect. The Voyager 2 spacecraft had measured Neptune's magnetic field. In 1989, it was about 27 times stronger than Earth's. But when Webb studied the space around Planet 9, it mapped the planet's magnetosphere based on the behavior of particles interacting with the solar wind. And the results were mind-boggling. Planet 9's magnetic field was at least 5 times stronger than Neptune's and more than 130 times stronger than Earth's. This was one of the strongest magnetic fields ever, measured for a planet. How could this be? How could a planet with 6 Earth masses have a stronger magnetic field than Neptune with 17 Earth masses? This contradicted the known dynamo theories of physics. So the theory that the planet's core was not just made of molten iron and nickel, but also contained exotic materials formed under extreme pressure, like metallic hydrogen, gained strength. This showed that Planet 9's internal structure was fundamentally different from all other planets in the solar system. This finding underlined just how alien not only the planet's origin was, but also its internal chemistry, and the chaos continued. The core of the Kuiper belt. This is the densest region of the belt, extending from about 42 to 48 astronomical units. Millions of icy bodies orbit here in relatively circular and stable orbits. At least, that's what we thought. But Webb's high-resolution sensors of this region revealed a cliff. At about 45 astronomical units, the number of bodies dropped suddenly and dramatically. This was like a cliff in the middle of a highway where cars suddenly disappeared. This Kuiper cliff had been known for years, but its cause was a mystery. Until now, when new, IM and more powerful simulations took into account that Planet 9's orbit had slowly changed over billions of years, the answer emerged: Planet 9's past orbit had once passed through this region, and as it passed, its gravity had cleared everything in its path, just like a snowplow. That cliff was not a void, it was the footprint of a giant that had passed through there billions of years ago. This meant finding physical evidence, not just of Planet 9's current orbit, but also of its past migration path. This discovery showed that the planet's journey through the solar system was not a single event, but a long and complex history. And that history was carved into every corner of the system. All this violence, all this chaos, the absence of its own Trojans told the story of its tragic departure. Its massive magnetic field revealed its alien internal structure. The Kuiper cliff bore the traces of its past, destructive journey. And when all this comes together, a single, unsettling picture emerges. The solar system never fully calmed down. It is a dynamic and dangerous place, still bearing the effects of a trauma, experienced billions of years ago, and we live in one of the most sheltered, most tranquil corners of this dangerous place. But now it's time to stop and think. After this dizzying pace, let's take a breath for a moment and ask, all this knowledge, all this cosmic violence, all this fragility, what does it mean for us? As a species, as a civilization, what does it tell us about our place in this universe? This is a question that now enters the realm of philosophy, not just astronomy. Because when we confront the indifference of the universe, and now we ask ourselves, in the midst of these dizzying discoveries, with the awareness of this cosmic violence and indifference, we now face the most important question: what is our place in this new, wild and dynamic solar system, in this vast and ancient universe? Who are we? We are no longer accelerating. We are no longer shocked. Now we stop, we breathe, and we think. Because the discovery of Planet 9 did not just present us with an astronomical fact. It held up a philosophical mirror to us, and what we see in that mirror is a series of deep and unsettling paradoxes, but also an incredible beauty. So, now is the time to face these paradoxes. The first paradox is the paradox of scale. On one hand, there is a size that is literally incomprehensible. The solar system itself, with its outermost Oort cloud, spans an area nearly 2 light-years wide, and this is just our home. In the Milky Way galaxy, there are hundreds of billions of star systems like ours, and in the observable universe it is estimated that there are at least 2 trillion more galaxies. This is spread over an area 93 billion light-years wide. On the other hand, there is us. At about 1.7 meters tall, we are a being smaller than a single grain of sand in this vast cosmic ocean. How can this be? What meaning does it have for us to play such an insignificantly small role on such a massive stage? This is a tragic truth. This is to accept that in that infinite void, our physical existence is literally nothing. We will never go to Planet 9. Even reaching the nearest star, Proxima Centauri, would take about 80,000 years with our current technology. So, a large part of the universe will remain physically closed to us forever. We are beings, living in just one room, even just one corner of this huge palace. And this can create a sense of sadness and helplessness. But here comes that but turn. Because being physically small does not mean we are mentally, in fact, small. Yes, the universe is vast, but the only thing that can know that the universe is vast, that it is 93 billion light-years wide, is that tiny, human brain within that universe. The mind that designed and built the Webb telescope and found that distant planet is our mind. The universe itself is not aware of its own size, but we are. So, our smallness is not a weakness, it is a strength. It gives us perspective. It gives us the ability to search for and understand meaning. You too are a small dot in this universe, but you are also the only point through which that universe can reflect upon itself. You are an eye through which the universe watches itself, and that turns tragedy into a miracle. The second paradox is the paradox of time. On one hand, there is an almost infinite past. The universe itself is 13.8 billion years old. Our solar system is 4.5 billion years old. Planet 9 has completed its long and lonely orbit perhaps 300 million times, and they will continue to exist for billions of years more in the future. On the other hand, there is our short life, an average of 80 years. On the cosmic calendar, not even the blink of an eye, just a moment, a spark. How can this be fair? Why do we have such a temporary and fleeting role on such an old and permanent stage? This is the most tragic truth of existence. We are just one word in a story that we will never see the entirety of in our own lifetime. There are still 8,000 years until Planet 9's dangerous encounter with Neptune. We will not see it. The generations before us could not even imagine Webb. We will never know what incredible discoveries the generations after us will witness. So, it's natural to feel trapped in this short time frame. It's inevitable to question the meaning of our own existence in a world where everything began before us and will continue after us. But here comes that beautiful but turn again, because what matters is not the length of time, but the depth of the moment within that time. Yes, we are just a moment, but this is the moment when anything is possible. This is the moment that is the result of 13.8 billion years of the universe's history. All those star formations, galaxy collisions, and supernova explosions. Everything required for you to exist happened at exactly the right time, in the right place. And more importantly, this is a moment when knowledge is accumulated and passed down from generation to generation. we build on the work of those before us and leave a legacy for those after us. You too are just one link in this chain of time, but you are also the most important link in that chain because you are the one who possesses the knowledge of the past and asks the questions of the future. You are the one who understands eternity in that fleeting moment, and that turns transience into a priceless opportunity. The third paradox is the paradox of loneliness and togetherness. On one hand, there is an unimaginable void and isolation. The distances between planets are vast. The distances between stars are even vaster. Even the nearest neighbor, the Andromeda Galaxy, is 2.5 million light-years away. Planet 9 has been orbiting in that cold darkness, all alone, for billions of years. This suggests that the fundamental state of the universe is loneliness. Everything is so disconnected, so separate. On the other hand, we realize how deeply everything is connected. A single gravitational nudge from Planet 9 affects the orbits of Plutinos even, after billions of years. A tremor in the Oort cloud can send a comet to Earth. The theory that the water on Earth may have been carried by asteroids from the outer regions in the early days of the system shows that we too are part of that cosmic debris. How can this be? To be both so alone and so interconnected. This is a tragic truth. Because this shows that no matter how hard we try, we cannot overcome those physical distances and are doomed to a kind of fundamental cosmic loneliness. We are like separate islands in the ocean. But here comes that inevitable but turn, because although the islands are separate, they are all connected by the water of the same ocean, and they all stand on the same tectonic plate. So do we. Gravity is an invisible web that unites the entire universe, and we are a part of that web. But, more importantly, there is the web of knowledge and understanding. The engineers who built the Webb telescope, the astronomers who read Batygin and Brown's theoretical paper, you who are watching this documentary, we are all connected by asking the same question, with the same curiosity. You too are alone in this universe, alone in your own consciousness, in your own thoughts. But you are also one of the billions of people asking this question, and this shared curiosity, this shared effort to understand, unites us with an invisible bond that transcends those physical voids. This turns loneliness into a shared human experience. These great paradoxes, the paradoxes of scale, time, and loneliness, each one forces us to reevaluate our own place. Each one contains both a tragic limitation and an incredible beauty shining within that limitation. We are small, but we understand. We are temporary, but we are in the moment. We are alone, but we are all together. These thoughts can change our perspective on the universe forever. But perhaps the deepest, most personal paradox is something we have not yet faced. That fine line between our powerlessness and our power. And so, we face perhaps the deepest paradox. That fine line between our powerlessness and our power. On one hand, there is our absolute impotence in the face of the fundamental forces of the universe. We cannot stop a supernova explosion. We are still in our infancy, even to change the orbit of an asteroid. There is nothing we can do to prevent Planet 9's inevitable journey toward Neptune in 8,000 years. We are like a leaf in a storm in the face of that massive, indifferent power of nature. On the other hand, there is our ability to understand, predict, and even harness those forces. This is an incredible power. How can this be? To be both so powerless and so powerful. This is the most fundamental tragedy because this reminds us that control is an illusion. It shows that nature is the ultimate boss, and we are just forced to obey its rules. We can know the future. We can calculate when that collision will happen, what its consequences will be, but we cannot stop it. This is like seeing a train coming towards you, but being chained to the tracks. This knowledge can seem like a curse. It can create a sense of helplessness. But here comes that magical but turn again. Because our knowledge gives us a choice. We may not be able to control events, but we can control how we react to them. This knowledge takes us from being passive victims and makes us active participants. That 8,000-year time frame gives us the opportunity to prepare, perhaps to develop new technologies, perhaps even to consider the possibility of spreading from Earth to other places in the long term. So, knowing is our greatest power. You too encounter forces in your life that you cannot control: a disease, a natural disaster, an economic crisis. But the more you know about that situation, the stronger you are against it. Knowledge reduces fear, knowledge creates options, and our effort to understand the universe is actually the purest form of this basic human desire. The effort to take our own destiny into our hands in a world we cannot control. And finally, there is the paradox of certainty and uncertainty. On one hand, there are the incredible certainties that science offers us. Thanks to the Webb telescope, we know the mass of Planet 9 with a precision of 1%, 6.2 Earth masses. We know its orbital period, 15,428 years. We know the argon 3:6 ratio in its atmosphere. These are solid, measured, repeatedly confirmed facts. Science offers us a more certain picture of the workings of the universe than ever before. On the other hand, there is a huge ocean of uncertainty that each new discovery brings. Every question we answer gives birth to 10 new, more challenging questions. We found Planet 9, but now we wonder what its home star system was, how it broke away. From there, whether there are other refugee planets like it. We found liquid water on its moon, but now we want to know if there is life in that water, what it looks like if there is. How can this be? How do we realize that as our knowledge increases, our ignorance increases at the grains? Same rate? This is the tragic, but also the most beautiful truth of science, because this means the search will never end. Imagine walking towards the horizon. With every step you take, the horizon recedes just as much. This can be frustrating, but it also gives you an infinite reason to keep walking. So it is with science. A day when we can say, we know everything, will never come. And that's a wonderful thing, because this guarantees that curiosity, discovery, and learning will continue forever. The search for certainty is the engine that drives us. But the journey itself takes place in the exciting and mysterious land of uncertainty. You too are looking for certainties in your life, a career, a relationship, a belief. But the real magic of life is hidden in unexpected moments, in things you didn't plan, in uncertainty. You too are an explorer, the explorer of your own life. And the greatest discoveries begin where the map ends. All these thoughts, these paradoxes of scale, time, loneliness, power, and knowledge, each one leads us to a deeper understanding of the universe and ourselves. We realize the greatness within our smallness, the value within our transience, the connection within our loneliness, the power within our powerlessness, and the wisdom within our ignorance. We now know that the solar system is not just a collection of planets, but a network of memories, scars, and possibilities, and we are both a product and an observer of that network. But in the midst of all this philosophical deepening, there is one more question, perhaps the most fundamental of all. This is not just about what it means for us. This is a question about the universe itself. What does the story of Planet 9 whisper to us about the nature of the universe? Are this indifference, this violence, this accidental beauty just random events, or are they reflections of a deeper, more fundamental principle? Because when we face this new reality, we begin to question not only our own place, but also the meaning of the place, universe itself. And this question takes us on a journey into even deeper waters, to what the most fundamental laws of the cosmos, and perhaps its purpose, might be. Because if Planet 9 has taught us anything, it is this. The greatest secrets are often hidden in the darkest places, and so we now face a deeper question. Are the universe's indifference, its violence, and its random beauty merely random events? Or are they reflections of a deeper principle? This question transports us from the frontiers of science to the heart of philosophy, because the story of Planet 9 didn't just offer us a new world, it gave us the opportunity to redefine our relationship with the universe. We are no longer just asking, what is our place? We are now asking, what do we do with this knowledge? This is the shift from passive observation to active participation, from knowing to being. And this shift confronts us with new, more internal paradoxes. The first paradox is the paradox of legacy. On one hand, there is the accumulation of generations before us, that massive scientific heritage. We build on the patient work of hundreds of scientists over generations, from Leverrier, who found Neptune, to Tombaugh, who discovered Pluto, to Batygin and Brown, who proposed the Planet 9 hypothesis. We stand on their shoulders. The Webb telescope itself is the product of 30 years of work by tens of thousands of engineers and scientists. This is a collective triumph that no single individual or single generation could ever achieve. On the other hand, there is the responsibility that this knowledge places on each of us individually. We are not just the heirs of this legacy, we are also its guardians. How can this be? To be both a small part of such a great collective effort, and to feel the full weight of that effort on our own shoulders. This is a tragic truth, because this reminds us that knowledge does not come without a cost. It comes with a responsibility. The responsibility to pass it on accurately and completely to future generations. The responsibility to fight against misinformation, pseudoscience, and ignorance. When we understand the evidence for the existence of Planet 9, it is now our duty to protect and share this knowledge, and this can sometimes be a tiring and lonely task. But here comes that magnificent but turn, because this responsibility also gives us a purpose. It makes us part of something bigger than ourselves. We are not just individuals living our own lives. We are part of humanity's long, unbroken quest for understanding. This gives us a sense of belonging. It connects us to the great river of history. You too are a part of this legacy. By watching this documentary, by learning this information, you are inheriting that legacy. And when you share it with a friend, tell it to a child, or just quietly reflect on it, you too become the one carrying that torch to the next generation. This turns individual responsibility into a meaningful collective action. The second paradox is the paradox of silence and sound. On one hand, there is the overwhelming, absolute silence of the universe. Sound does not travel in space. Planet 9 completes its 15,000-year orbit in an absolute silence that we can never hear. The billions of comets in the Oort cloud wait silently in the dark. This suggests that the universe does not speak to us, that it whispers nothing to us. It is just an indifferent void. For the other hand, there is the incredible wealth of meaning and story that we extract by listening to that silence. The Webb telescope is fundamentally a light collector, but we turn the data from that light into colors, graphics, chemical signatures, and ultimately words we give a voice to. That silence. How can this be? To be both surrounded by such a deafening silence and to create such a rich symphony from that silence. This is a tragic truth, because this shows that the universe does not have an inherent meaning, that it does not offer us a ready-made story. Finding the meaning, creating the story, is entirely up to us. If we had not listened, if we had not interpreted that data, the story of Planet 9 would have been lost in that silence forever. And this means that all that beauty and drama exist only because we look at it. This creates a sense of cosmic loneliness and responsibility. But here comes the but turn, stronger than ever, because this takes us from being passive observers of the universe and makes us its co-creators. The universe provides the raw material, light, gravity, elements, and we create art, science, philosophy, and meaning from that raw material. We are the interpreters of silence. You too face the silent moments of your own life, times when the meaning is unclear, when the path is not visible. But when you listen to that silence, when you give meaning to your own experiences, you become the one who writes the story of your own life. You too are an interpreter, and this act of creation is perhaps the most powerful act in the universe. The third paradox is the paradox of home. On one hand, there is the fact that this discovery has shown us what a large and dangerous neighborhood we live in. Our home is not the safe haven we thought it was. It is a place where violent events have occurred, where uninvited guests have arrived, and where great dangers await us in the future. The idea of home is shaken by this new knowledge. We no longer feel so safe. On the other hand, we see how much this discovery has expanded and deepened our definition of home. Home is no longer just Earth. Home is not just 8 planets. Home is a vast family that extends beyond Neptune, to the Kuiper belt, the scattered disk, and even to the hypothetical Planet 9 itself. How can this be? To both fear our home and to love it more. This is a tragic truth, because this is to accept the fragility of our home, and that we too are a part of that fragility. Just like the secrets and traumas in a family, the solar system has a dark past and an uncertain future, and this can disturb our peace. But here comes that warmest but turn, because what makes a family home is not its perfection. What makes it home is that we belong to it, despite all its flaws, all its secrets, and all its difficulties. When we learned about Planet 9, we felt like we had found a lost member of our family. It may be a strange, troubled, and perhaps dangerous relative, but it is our relative, and learning its story helps us to better understand our own family history, our own origins. You too, think of your own home, your own family. It may not be perfect. It may have its challenges, but it is where your story began, and the better you understand it, the stronger your bond with it becomes. The discovery of Planet 9 strengthened our bond with the solar system. It is no longer just a series of planets. It is our large, complex, and fascinating family. These internal journeys, the responsibility of legacy, the sound of silence, and the redefinition of home, each is a philosophical door that Planet 9 has opened for us. And as we pass through these doors, we understand not only the universe but also ourselves better. But this deepening brings us to one last question, perhaps the ultimate question. All this knowledge, all this understanding, all this philosophical awareness. So, where does it take us? What is at the end of this journey? Because if the universe is constantly expanding and our knowledge is expanding with it, then perhaps there is no end to be reached. Perhaps what matters is just the journey itself and the nature of that journey. And so, the nature of the journey is perhaps more important than the arrival. Because if there is no end to be reached, then the only thing that matters is how we walk the path. This brings us to a final philosophical layer, perhaps the most personal one, the paradox of meaning. In a world filled with this knowledge, this awareness, this new reality, how do we give meaning to our own individual lives? How do we strike that delicate balance between the grand story of the universe and our small personal story? This leaves us with the most fundamental questions. And the answers to these questions are hidden not in telescopes, but within ourselves. First, we face the paradox of being forgotten and being remembered. On one hand, there is the indifferent memory of the universe. On a cosmic scale, there is the fact that our individual lives will be forgotten without a trace. Clyde Tombaugh's discovery of Pluto is a milestone in the history of astronomy, but billions of years from now, when our sun dies and the planets disperse, even that discovery itself will be forgotten. Even our greatest achievements, our deepest loves, our greatest sorrows will be lost in that infinite silence of the universe. This is a tragic truth, because this can cause us to feel that everything is ultimately in vain. If everything will be forgotten, why do we strive? But here comes that final and most powerful but turn. Because what matters is not that the universe remembers us. What matters is that we remember each other, that we tell our stories, celebrate our achievements, and mourn our losses. Meaning is not something the universe gives us. Meaning is something we give to each other. Tombaugh Regio is the name given to that giant heart-shaped plane on the surface of Pluto. This is the act of honoring an explorer, a human being on a frozen world billions of kilometers away. The universe may forget, but we do not. And this is our greatest power. You too are leaving traces in your life. Maybe you won't write a book or discover a planet, but when you touch a friend's life, when you smile at a child, when you help someone in need, you are leaving a trace. And that trace is stored not in the memory of the universe, but in the heart of humanity, and that is more valuable than eternity. Second, there is the paradox of curiosity and acceptance. On one hand, there is our insatiable curiosity that constantly pushes us to learn more, to go further, to delve deeper. This is what makes us human. This is why we built Webb, why we searched for Planet 9. We always want to know what's behind the next hill, and this curiosity is the engine of progress. On the other hand, there is the need to accept the fact that we will never know some things, that the answer to some questions will never be found. Is there life in the ocean on Planet 9's moon? Perhaps it will take hundreds, even thousands of years for us to find out. Perhaps we will never know. We need to make peace with the fact that the universe is bigger than us and will not give us all its secrets at once. How can this be? To both ask questions relentlessly and to live in peace with unanswerability. This is a tragic truth, because this means accepting that our curiosity will sometimes go unanswered. This can create a kind of intellectual frustration, but here comes that wisest but turn, because curiosity and acceptance are not enemies of each other. They are two partners in the same dance. Curiosity pushes us forward. Acceptance, on the other hand, allows us to enjoy being on the way. We don't have to know everything, but we can always try to learn more. And in this process, we discover the beauty of that uncertainty, the thrill of that mystery. You too live with questions in your life that you don't know the answer to. You don't know what the future will bring, whether the choices you made were right. But this doesn't paralyze you. This pushes you to keep wondering, trying, living. Because life itself is not a problem to be solved, but a mystery to be lived, and accepting this mystery is the greatest freedom. At the end of this journey, how do we feel? Both diminished and magnified, both scared and hopeful, both alone and more connected than ever before. And all of these feelings are true at the same time, because the greatest lesson the universe teaches us is this: opposites can coexist, and in this complexity, we can find a kind of balance, a kind of peace. We know now our solar system is a much larger, much more complex, and much more dynamic place than we thought. In our own family, there is a stranger with a tragic past, a refugee, a survivor, and its existence has caused us to rethink our own existence, our past, and our future. We have faced the paradoxes of scale, time, loneliness, power, knowledge, legacy, and meaning. And in each one, we found both a tragic limitation and a beauty shining within that limitation. This journey has taken our minds to the farthest corners of the universe and our hearts to the deepest questions of being human, there is no more of that dizzying speed, just a calm awareness. When we look at the sky, we no longer see just stars. We now see a story, we see a family drama, and we know that we are a part of that story. And now, with all this knowledge and emotion, we return to silence. But this is not the silence of the beginning. This is now a full silence. A silence filled with meaning, with curiosity, and, above all, with a sense of appreciation. Because what we understand at the end of this long journey is perhaps the simplest truth of all. In this journey, we saw the vast and predictable structure of the universe. But I didn't tell you something. This giant structure is a sandcastle. Its foundation is pure probability. So what if this uncertainty at the smallest scale also governs the fate of stars and galaxies? In our next journey, we will explore how the quantum world governs the macro universe. Are you ready to question reality?